Now it's a segment of a chord. A point on a chord divides it into two segments. Please understand this. A point on a chord divides it into two segments. Now the segments formed are by internal division or external division. The segments formed when internally divided are AR and RB. Now if you see here, R is a point on the chord AB and it is internal division, therefore, and the internal division, and the internally divided segments are AR and RB. Now the point S is also on the chord AB and it is externally divided, and the segments are SA and SB. So remember this, that a point on a chord divides it into two segments. It can be internally divided or externally divided. A very important property again. Now angles in the alternate segment is a very important property again. A chord and a tangent to a circle form alternate segments. A chord and a tangent to a circle form alternate segments. The angle formed by a chord and tangent is angle BAQ. The angle formed in the segment by the chord, angle AMB, is the angle in the alternate segment with reference to the angle BAQ. Similarly, the angle ANB is the angle in the alternate segment with reference to the angle formed by the tangent and the chord, angle BAP. And please remember, angle BAQ is equal to angle AMB and angle BAP is equal to angle ANB. Now let me explain this with the help of the diagram here. Now we have a circle here. AB is the chord and PAQ is the tangent. A is the point of contact. Now the angle between the chord and the tangent is angle BAQ. The angle in the alternate segment is angle AMB. The angle BAQ is equal to angle AMB. Remember that. And also the chord AB forms another angle with the tangent, and that is BAP. And the angle in the alternate segment is BNANB or BNA, and angle BAP is equal to angle ANB. A very important property which you have to remember. Therefore remember, the angles between a chord and a tangent at the point of contact are respectively equal to the angles in the alternate segment. Very important property, remember. So for angle BAQ or for angle BAQ, the angle in the alternate segment is AMB. For angle BAP, the angle in the alternate segment is ANB, and ANB angle ANB is equal to angle BAP, and angle BAQ is equal to angle AMB. Remember, very important property again. Now the next important point of our study is cyclic quadrilateral. A quadrilateral, the vertices of which are concyclic or lie on a circle, is called cyclic quadrilateral. A quadrilateral, the sides of which form the chords of a circle, is called a cyclic quadrilateral. ABCD is the cyclic quadrilateral here. Let me explain this to you. Now ABCD is a cyclic quadrilateral because the vertices of the quadrilateral lie on the circle, or the vertices of the quadrilateral are concyclic, and also the sides of the quadrilateral form the chords of a circle, and therefore the quadrilateral is cyclic. Remember that. The opposite angles of a cyclic quadrilateral are supplementary. That means angle A plus angle C is 180, angle B and angle D is also equal to 180. That is, the opposite angles of a cyclic quadrilateral are supplementary. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, and it's very important property here. Now if you see here, ABCD is the cyclic quadrilateral, and when I extend AB to E, I get exterior angle, that is CBE. Now the angle CBE, which is the exterior angle of the cyclic quadrilateral, is equal to the interior opposite angle. The opposite to this angle is this, therefore angle ADC is equal to angle CBE, and that is what you have to remember. That is, angle CBE is equal to angle ADC. Very important property again. A quadrilateral in which the opposite angles are supplementary is a cyclic quadrilateral. Now if you look here, if you take this quadrilateral ABCD, this will be a cyclic quadrilateral if angle A plus angle C is 180, or angle B plus angle D is equal to 180. Remember that. Now in any circle, the tangent and the radius at the point of contact are perpendicular to each other. Let me explain this to you. Now if you have a circle here, and APB is the tangent and OP is the radius. and they meet each other at the point of contact, that is P. Now the angle OPB is equal to 90 degrees. That means in any circle the tangent and the radius at the point of contact are perpendicular to each other. Now very important property, a line drawn through the end point of a radius and perpendicular to it is a tangent. What is the meaning of this? We have a circle, OP is the radius, P is the end point of the radius, and if you draw a line APB to the end point of the radius, then remember that that is such that angle OPB is 90 degrees, then APB is a tangent. A very important property, again remember that. Therefore a line drawn through the end point of a radius and perpendicular to it is a tangent. Relation of length of a chord, radius of a circle. Now let us understand this here. Now we have a chord AB here, and the R is the radius of the circle, and D or OC is the distance of the chord AB from the center. Now if I see the triangle here, triangle OBC, angle OCB is 90 degrees. By applying Pythagoras theorem, we understand that R square is equal to L square plus D square. This relation can be used to find one unknown. Knowing two values, we can find the third value. It's a very important relation and useful for calculation. So these are important properties of circles which we have learned in two parts, part 1 and part 2. Please go through all these properties, understand these properties, and many of them are proved with like theorems which you'll be learning later in your higher classes. But these properties are very useful in geometry and to prove theorems, and also for calculations of different types of examples. Please read this again and again, listen to what I have spoken to you, take a book, write it down, and keep it as a reference for you for your future use. Thank you.